We now want to determine if a function has an inverse. What is an inverse? Well, if y equals f of x, that maps the x's over to the y's. F inverse of y equal to x maps each of the y's back to its original x's. So when does this inverse actually exist? The function has to be one-to-one everywhere. Now remember, we have a function test. It's called the vertical line test. We now have a one-to-one test, which is a horizontal line test. And this tests to see if a function is one-to-one. Another way of being sure that the inverse exists, if the function is strictly monatomic. That means that it's increasing everywhere or that it's decreasing everywhere. So here's how we find an inverse. First, we solve the equation for x, interchange the value of x and y, and then double check by seeing if the composition FO, F inverse is equal to x. We also have to go the other way. So let's take y equal 3x minus 2. We want to determine, is this in fact, does this function have an inverse? So is it one-to-one? The graph on the side is in green, and we can use the horizontal line test. It never hits twice. So therefore, an inverse does in fact exist. Now to find that, let's use our process. First solve for x. So we have y plus 2 equals 3x. And then we divide through by 3. Let me switch sides as well. So x equals y plus 2 divided by 3. Now we want to interchange the x and y value. So y now becomes x plus 2 divided by 3. So this will in fact be our f inverse of x, which the notation is f to the negative 1 power. So here is our inverse function. Now the next thing we want to do, if we look at the graph, the blue line is our inverse function, x plus 2 divided by 3. You may notice a symmetry here between the green and the blue line. This is the line y equals x, and anytime you find the inverse, there will be a mirror image between its inverse and the original function. Let's continue by checking to make sure that our inverse is in fact correct. The way we would do that, first let's take f of f inverse of x. So f inverse is this guy, x plus 2 divided by 3. We're going to take that and plug it in the place of x in our original equation. So we have y equals 3 times, and what is the x? X plus 2 over 3 minus 2, which gives us, the 3's cancel, we're left with x plus 2 minus 2, which gives us x. Let's go the other way. Let's take f inverse of f of x. We replace f of x with our original equation, 3x minus 2. And now we replace all of this into our x value of our inverse. So we have 3x minus 2. Then the rest of the equation is plus 2 divided by 3. The 2's cancel out. We're left with 3x over 3, which gives us x. Because we wound up with x, as a result of both of these, we know our equation is correct, and we can look at our graph.